There are 600 billion stars in the Milky Way. There are 2 trillion galaxies in the observable universe. By any measurement that science has ever devised, we are nothing. A barely visible speck on a barely visible rock circling a perfectly ordinary star in the unremarkable outer arm of a galaxy that the universe will never notice. We have always known this. Philosophers have written about it for centuries. Astronomers have calculated it for generations. Priests have preached the smallness of man against the immensity of creation since before there were words for creation. And for most of human history, the knowledge changed nothing, because we couldn't see it. We could calculate the distance to the nearest star. We could theorize the age of the universe. We could map the positions of galaxies so distant that the light reaching our telescopes left before the Earth existed. But we could not see our own home from the outside. We were a species that had never looked at its own face. And then one December morning in 1968, a man pointed a camera out of a window, and everything changed. If you have ever stood in front of something so vast that you forgot for a moment what size you were subscribed, because what comes next is not about space. It is about what space does to the way you see the one place in the universe that has ever mattered to any of us. And it starts with the weight of a globe you held in school, one you turned in your hands and never fully understood. Every American who went to school between 1950 and 1990 remembers a globe on the teacher's desk. Blue oceans, green and brown continents. The satisfying weight of it in your hands, the way it spun on its tilted axis when you gave it a push, and the sound it made, a soft hiss of resistance against the metal ring. You could find your country on it in 3 seconds. You could fit the entire planet in your lap. That globe is a lie, not a malicious one. A useful one, the way all maps are useful, lies simplifying the impossible into the manageable, but a lie nonetheless. And before we talk about what happened when we left this planet and looked back at it, we need to spend a few minutes dismantling the globe. Because what Earth actually is not as a symbol, not as a classroom model, but as a physical object in space is so much stranger and so much more extraordinary than anything a painted sphere can contain. Start with the basics. Earth is approximately 12,742 kilometers in diameter. That number means nothing to a human nervous system. So here is a version that does if you drove at highway speed without stopping. 24 hours a day, it would take you more than 14 days to travel the distance from one side of the Earth to the other. The oceans you crossed in that journey, the Pacific, which alone covers more area than all of the world's land masses combined, would require most of that time on their own. Earth is enormous by human standards, and cosmically it is a grain of sand on a beach that has no horizon. If Earth were a basketball, the moon would be a tennis ball sitting about 7 meters away. Not 7 feet, 7 meters. The moon which we watch rise every evening, and which has guided human navigation and agriculture and storytelling for 100,000 years, is on the basketball Earth scale sitting across the room. The sun on that same scale would be a sphere 2.5 meters wide, positioned 270 meters down the road. That is how much nothing there is between here and there. But here is the thing that the globe on the teacher's desk never told you. Earth is not blue and green. Not really. From orbit, the planet is mostly white cloud cover, wraps it constantly. A churning, dynamic, never-repeating pattern that no globe can capture because it changes by the hour. The oceans are not the uniform blue of paint. They are a specific luminous turquoise near the shallows, a deep and almost purple indigo in the open ocean, a grey-green in the cold northern seas. The continents are not bold-colored shapes with clean edges. They are fractal and imprecise and ambiguous at their coasts, land and water negotiating their boundary in 1,000 river deltas and wetlands and tidal zones that no border can cleanly define. Earth is not the globe. The globe is a story we told ourselves about Earth before we could see it properly. And in 1968, we finally saw it properly. But before we get to that moment, before we talk about what happened when a human being looked at Earth from outside its atmosphere, for the first time we need to understand why that view was so staggering. And to understand that you need to understand what Earth is doing just to exist. Consider the temperature right now wherever you are. If you're reading this in a house or an office or a coffee shop, the temperature around you is probably somewhere between 60 and 75 degrees Fahrenheit. You are not thinking about the temperature. It is simply there. The background condition of being alive on this planet. Here is what the background condition requires. Without the greenhouse effect, without the thin layer of carbon dioxide and water vapor and methane that the atmosphere holds in place around the planet, Earth's average surface temperature would be 18 degrees Celsius below zero. Not cold by Antarctic standards, cold by the standards of liquid water. At -18, the oceans freeze, not at the poles everywhere. The great rivers lock solid, the water cycle stops. The chemistry that makes life possible, the chemistry that requires liquid water as its medium, shuts down. Earth becomes a mirror of ice reflecting sunlight back into space, cooling further, locking itself in a feedback loop it cannot escape. The atmosphere prevents this. It holds 33 degrees of warmth, a margin so precise it is almost impossible to think about without feeling something adjacent to vertigo. 33 degrees is the difference between a living world and a dead one. Between you reading this and nothing ever having happened here. And then there is the position. Earth orbits the Sun at a distance we call 1 astronomical unit, 150 million kilometers. Venus orbits at 0.72 of that distance. On Venus, the surface temperature is 465 degrees Celsius, hot enough to melt lead, hot enough to destroy any carbon-based chemistry we know of. The greenhouse effect on Venus has gone catastrophically wrong. CO2 in its atmosphere traps heat so efficiently that the planet cooks itself from the inside out. Venus is not a lifeless world because it was unlucky. It is a lifeless world because it is 5% too close to the Sun. Mars orbits at 1.52 astronomical units, 20% further from the Sun than Earth. On Mars, the average surface temperature is -60 degrees Celsius. Liquid water cannot exist on its surface. The chemical reactions that life requires cannot proceed. Mars is not a lifeless world because it was unlucky either. It is a lifeless world because it sits just outside the window. Earth sits in the middle, precisely in the middle. In the zone, scientists call it the habitable zone, the Goldilocks zone, the circumstellar zone of life where liquid water is stable on the surface. The zone that is in this solar system, inhabited by exactly one planet. This is not a story about luck. Luck is a human category. It implies someone who could have been unlucky. What this is instead is something harder to name and more important to feel. Earth is the consequence of physics, chemistry, and 4 billion years of very slow iteration. And the consequence is the most complex thing that physics and chemistry have ever produced. A world that contains within it both the Pacific Ocean and the science of the Pacific Ocean, both the spider and the taxonomy of spiders, both the storm and the poem about the storm. The globe on the teacher's desk never told you any of this. Space did. Before you see the whole planet, before we get to the photographs, the astronauts. The moment everything shifted, there is something you need to understand about the atmosphere. Not the weather, not the air quality, the atmosphere as architecture, as the physical barrier that stands between every living thing on Earth and the void. Hold an apple in your hand. Feel the skin against your palm, the thin, taut membrane that separates the fruit from the air. Now understand the ratio of the Earth's atmosphere to the Earth itself is approximately equal to the ratio of an apple's skin to the apple. Carl Sagan, the astronomer who spent his life translating the universe into human terms, put it this way: the atmosphere is to Earth what a coat of varnish is to a schoolroom globe. You wouldn't even call it a layer. You would call it a film. The atmosphere extends to approximately 100 kilometers above Earth's surface. Earth's radius is 6,371 kilometers. The atmosphere is proportionally 1.5% of that. If you scaled Earth down to the size of a standard classroom globe, about 30 centimeters in diameter, the breathable atmosphere would be thinner than a single sheet of printer paper wrapped around it. Everything that has ever breathed, every forest, every ocean, every creature with lungs or gills or spiracles lives inside that sheet of paper. Astronauts on the International Space Station describe looking down at Earth's edge and seeing what they call the thin blue line. On the lit side of the planet, the side in sunlight, the atmosphere glows a specific impossible blue against the black of space. Not the sky blue we see from the ground, which is the result of sunlight scattering through the full depth of the atmosphere. This is thinner, purer, almost desperate in its luminosity. The thin blue line of the day side. On the dark side, the side in night, there is something else. A thin green line. Airglow scientists call it oxygen and nitrogen atoms in the upper atmosphere, energized by solar radiation during the day, releasing that energy as light in the dark. A faint continuous glow marking the upper edge of the atmosphere from the outside. From 400 kilometers up, you can see where the air ends. You can see where everything ends. Every sound you have ever heard existed only because sound waves have a medium to travel through. Every conversation, every piece of music, every thunder, every child's laugh, all of it required the atmosphere to exist. Space is the universe's default condition. It is silent and airless and lethal to carbon-based life. Earth's atmosphere is the exception, the anomaly, the thing that should not, by the statistical weight of the cosmos, be there. And here is what we discovered when we went high enough to see it from the outside. It is not infinite. It is not permanent. It is not the dome of heaven that every ancient culture believed it was. It is a film. And on the other side of that film, 20 miles above the average flight altitude of a commercial aircraft, 19 miles above the point where the pressure drops low enough to boil your blood, is a silence so complete it has no name in any human language. This is what space taught us about Earth. Not that the universe is vast, we knew that. That our protection is thin. That the boundary between being alive and not is measured in kilometers that a determined person could theoretically walk. That everything we have ever been and ever loved and ever built exists inside. A layer of air so thin it would not register as a smudge on a photograph of a basketball. We had to leave to know this. We had to leave to understand what we had. To understand what happened in December of 1968, you have to understand what December of 1968 felt like. Martin Luther King Jr. had been shot on a hotel balcony in April. Robert F. Kennedy had been shot in a hotel kitchen in June. The Democratic National Convention in August had devolved into street battles between police and protesters that the whole country watched on live television. The Vietnam War was consuming 50,000 American lives and producing every day footage that made the previous day's footage seem bearable by comparison. The year had been long and violent and exhausting in a way that did not feel like it would end when the calendar turned. On December 21st, 3 men climbed to the top of the largest rocket ever built and rode an explosion into space. Frank Borman was the commander, steady, military, focused entirely on the mission. Jim Lovell was the navigator, precise, experienced, a man who had already been to space twice and knew what to expect. And Bill Anders was the lunar module pilot, the youngest of the 3, a nuclear engineer and fighter pilot assigned to photograph the moon's surface for potential Apollo landing sites. His job during the mission was to look at the moon, not at Earth, the moon. 3 days after launch, Apollo 8 became the first crewed spacecraft to break free of Earth's orbit. The crew crossed the 64,000-kilometer mark, the furthest any human being had ever been from Earth, and kept going. They watched Earth shrink in the window behind them. By the time they reached lunar orbit, Earth was not a world filling their sky. It was a sphere, round and complete and recognizable from every side. On December 24th, Christmas Eve, they began orbiting the moon. On the 4th orbit, the spacecraft was rotating through a new orientation, when Bill Anders looked out his side window and saw something that was not in the mission plan. Earth was rising over the moon's horizon. Not slowly the way the sun rises over Earth, the moon rotates too slowly for a genuine rise. What Anders saw was the result of the spacecraft's own rotation, a geometry of motion and timing that produced in his window for a few brief minutes the sight of Earth appearing above the grey cratered stillness of the lunar surface. Blue, white, alive, impossibly heartbreakingly alive against the black. His first words recorded on the mission audio were, "Oh my God, look at that picture over there. Here's the Earth coming up. Wow, is that pretty?" Not "there is Earth." Not mission control. "We have an extraordinary view." Not even a coherent sentence, a gasp. A man from Texas trained in nuclear engineering and test piloting and orbital mechanics, confronted with a sight that none of his training had prepared him for, saying, "Wow, is that pretty?" He fumbled for color film. Lovell called out, "Give it to me," as the view began to recede. The audio from those 40 seconds is one of the most human recordings in the archive of space exploration. 3 highly trained professionals temporarily losing their professional composure in the presence of something their instruments could not measure and their checklists could not contain. Bill Anders took 3 photographs in those 40 seconds. One of them became known as Earthrise. It shows Earth above the moon's horizon, small in the frame, which is part of what makes it devastating, because the smallness is accurate. Bright blue and white against the absolute black of space, with the grey, barren moonscape filling the foreground. The moon is in every way larger than Earth in the image. And yet Earth is all you see. On Christmas Eve, the crew of Apollo 8 held a live television broadcast from lunar orbit. They read from the book of Genesis. Jim Lovell said, "The vast loneliness is awe-inspiring. It makes you realize just what you have back there on Earth." 3 days later, they splashed down in the Pacific. President Nixon had a print of Earthrise sent to every world leader on the planet. Within 18 months, 20 million Americans, 1 in 10, had participated in the first Earth Day. By the end of 1970, the Environmental Protection Agency had been created. The Clean Air Act passed. The Clean Water Act passed. The National Environmental Education Act passed. The most significant legislative period in American environmental history was compressed into 2 years following a single photograph. Nature photographer Galen Rowell called Earthrise the most influential environmental photograph ever taken. National Geographic photographer Brian Skerry said, "It's clearly the most important photograph ever made. It was humanity seeing itself in a mirror for the first time." Bill Anders. 50 years later, we set out to explore the moon and instead discovered the Earth. He spent the last decades of his life trying to explain what that meant. He never quite succeeded, not because the explanation was beyond him, but because the experience exceeded the capacity of any explanation. Some things require distance. Some things can only be understood from far enough away. Earthrise showed us Earth from 384,000 kilometers away. What happened when we looked from 3 billion miles further? Section 2.2. The pale blue dot. The hardest photograph, 1230 to 1530. Carl Sagan was not a sentimental man. He was a scientist, rigorous, precise, constitutionally suspicious of anything that could not be measured, tested, and reproduced. He spent his career translating the universe into human terms, not because he thought the universe was gentle, but because he thought humans needed to understand the scale of what they were dealing with. The universe did not care about us. Sagan knew this. He wanted us to know it too. He thought the knowing was important. In 1981, while Voyager 1 was completing its primary mission, photographing Jupiter and Saturn and their extraordinary improbable moons, Sagan proposed something that most of the Voyager team thought was pointless. He wanted the spacecraft to turn its camera around and photograph Earth. From where Voyager was, he knew Earth would be essentially invisible, too small to image in any useful detail, too small to see with the naked eye from that distance. The photograph scientifically would be worthless. That was precisely the point. It took him 8 years and 6 separate requests to get NASA's approval. The concerns were real. Pointing the camera near the sun at that distance risked permanently damaging the imaging system. The science team was being laid off. Resources were thin. There were better uses of the final moments of Voyager's camera capability. Sagan persisted. On February 14, 1990, Valentine's Day Voyager 1 warmed up its cameras for 3 hours. It had just crossed the orbit of Neptune. It was 6.4 billion kilometers from Earth, moving at 64,000 kilometers per hour, heading out of the solar system forever. Mission controllers in Pasadena sent the commands. Voyager turned. Its cameras swept across the solar system, capturing 60 images: the planets, the sun, the emptiness between them. And then at 4:48 Greenwich Mean Time, they captured Earth. Earth occupied 0.12 pixels in the image, not 0.12%, not a fraction of the frame, a fraction of a single pixel. A pale blue dot, barely distinguishable in the original from a camera artifact, caught in a scattered band of sunlight that illuminated nothing except its own accidental poetry. At 5:22, Greenwich Mean Time Voyager's cameras were powered off forever. The final transmission from those cameras, the last data they would ever send, was Earth the size of a period at the end of this sentence, photographed from a distance that the light it reflected took 5 hours and 36 minutes to cross. The image data took 2.5 months to reach Earth. The final frames arrived on May 1, 1990. When the image was processed and printed and mounted on the wall of the Voyager Mission Control Room at JPL, something unexpected happened. The engineers who had spent years of their lives on this mission, the mathematicians, the navigators, the instrument specialists, people who worked in orbital, mechanics and radio telemetry, and the dry grammar of scientific measurement would stop in front of it. They would look at it for a long time, and they would reach out and touch it. Not to test the paper, they would press their hand against the image as if pressing against a window. against the glass of a vessel very far from home. The print had to be replaced regularly, so many people touched it. Sagan wrote about the image not as a scientific result, but as something closer to a prayer, addressed it seems not to any god, but to the planet itself. "Look again at that dot," he wrote. "That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was lived out their lives, on a mote of dust suspended in a sunbeam." He continued, "The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. And then, at the end, after the devastation, after the scale, after the humbling, he pivoted, not to despair, to the only reasonable conclusion. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known." The smallness of Earth for Sagan was not nihilism. It was the most important moral argument he knew how to make. If we are this small, if everything that has ever mattered to any human being happened on something that does not register as a whole pixel from the edge of our own solar system, then what happens on that pixel is everything. There is nowhere else. There is no cavalry coming from another star. There is only here, only this, only the choices we make on the most improbable dot in the observable universe. On December 7, 1972, the crew of Apollo 17 lifted off from Kennedy Space Center for the Moon. They were the last. After them, no human being has traveled beyond low Earth orbit. After them, no human eye has seen the full face of Earth from that distance. As their spacecraft accelerated away from Earth, moving faster than any previous crewed mission, on the trajectory toward the Moon, astronaut Jack Schmitt pointed his camera out the window at approximately 45,000 kilometers altitude, with the sun positioned directly behind the spacecraft, fully illuminating the planet below. He pressed the shutter. The resulting image is called the Blue Marble. It is the only photograph of the fully illuminated Earth ever taken by human hands. Every other whole Earth image in existence before and after was taken by a machine. The weather satellites, the environmental monitoring instruments, the deep space probes machines. The pale blue dot was a machine. The stunning DSCOVR images from the L1 Lagrange point are machines. The Blue Marble is the only time a human being holding a camera looked out a window and captured the full face of the planet they came from. Apollo 17 splashed down on December 19, 1972. The last humans to see Earth whole from space stepped out of their capsule and onto a recovery ship and went home. As of this recording, more than 50 years have passed. The people alive today who watched the moon landings on television as children are now in their 60s and 70s. And no one in all that time has been far enough away to see what Jack Schmitt saw. The Blue Marble is not just a photograph. It is the last photograph, the last look. There is a particular kind of grief that comes not from loss, but from interruption, from the sense that something extraordinary was begun and then set aside before it was understood. We went to the moon 6 times. We took one genuine portrait of our home. And then we came back. And the conversation that the photographs were starting, the conversation about what we are, where we live, how extraordinary and fragile the address is. That conversation has continued for 50 years without the direct experience of the view that started it. We have been talking about what the astronauts saw. We have not been back to see it ourselves. Let's be careful here. Let's be very careful, because this is the part of the story that is easiest to get wrong. In 1987, a space philosopher and author named Frank White published a book called The Overview Effect. He had spent years interviewing astronauts about what it felt like to see Earth from space. What he found, and what has been confirmed by every study since, including rigorous psychological research from Penn and Oxford and NASA, is that something consistent and reproducible happens to a human being when they see Earth whole, from outside its atmosphere for the first time. Not something mystical, not something that requires belief in anything, not an experience that is described differently by religious people versus secular ones, by Americans versus Russians, by engineers versus scientists. The same experience, independently reported across 60 years of spaceflight by every astronaut who has looked out that window. Psychologists at the University of Pennsylvania, studying the phenomenon with the rigor they would apply to any cognitive or emotional response, identified the consistent features. First, unexpected, overwhelming emotion. Not the emotion you were prepared for, not the professional pride of a mission milestone, but something that bypassed the preparation entirely. Second, a perception of beauty so intense it exceeds any previous reference point. Third, and this is the strangest, the most consistently reported, the hardest to explain, a radical collapse of the sense of separation between the self and everything else. A feeling of connection to every other human being, simultaneously experienced not as an idea, but as a sensation. Fourth, a lasting change in values specifically around the protection of Earth and the irrelevance of the divisions between people. Researchers at Penn called it a state of awe with self-transcendent qualities, precipitated by a particularly striking visual stimulus. That is the scientific version. Here is the human version as told by the people who experienced it. Astronaut Jessica Watkins from the International Space Station's cupola. What you realize is every single person that you know is sustained, and inside of that green line, and everything else outside of it is completely inhospitable. You don't see borders. You don't see religious lines. You don't see political boundaries. You see that it's a single planet with a shared atmosphere. Astronaut Victor Glover, on returning to Earth. You come back to sea level, and then you have a choice. Are you going to try to live your life a little differently? Are you going to really choose to be a member of this community of Earth? William Shatner, 90 years old on a Blue Origin suborbital flight in 2021. A man who had spent his career playing a space captain on television, stepped out of the capsule and could not speak normally for several minutes. When he found words, they were, "There is mother and earth and comfort. And there is there death? I don't know." It was so moving to me. This experience, it's something unbelievable. David Yaden, the Penn psychologist who studies the overview effect, noted what makes it scientifically remarkable. Space is so fascinating because it's a highly scientific, highly secular environment. We don't often think of these very strict scientists reporting these blissful moments. And the experience is not just individual, it is consistent, reproducible. Every person who has this specific visual experience from this specific vantage point reports the same categories of response. This is in the history of psychology essentially unprecedented, a reliably reproducible transformative experience requiring no ritual, no preparation, no shared belief system triggered by a single visual input. See Earth whole from outside its atmosphere. Everything else follows. Not A, but B. The overview effect is not a spiritual experience that happens to occur in a scientific environment. It is what happens to a human nervous system when it finally receives information it was built to process, but has never had access to before. We evolved over millions of years on the surface of a planet. The part of our brain that processes social connection, threat, belonging, and identity, the part that defines who is us and who is them, was calibrated for one object, Earth. And when a human being finally sees that object from the outside whole, complete, impossibly beautiful, impossibly fragile something in the ancient machinery of perception shifts, not in our beliefs, in our seeing. The overview effect is not a feeling. It is a correction. The mathematics of the overview effect contains a quiet tragedy. As of today, approximately 700 human beings have ever been to space. The global population is 8.1 billion. The percentage of humans who have directly experienced the view that changes everything is 0.0000086%. That is not a rounding error. It is a statistical category so small it does not have a name. It is the kind of number that describes an extreme outlier, a singular event, an experience so rare it barely registers as a human experience at all. And yet every single one of those 700 people came back changed. Every single one has spent time in interviews, in books, in lectures, in quiet conversations, trying to transmit what they saw. Frank White said it was the whole point of naming the overview effect, to create language for the experience, because language is the only transmission medium available to the 8 billion who haven't had it. The photographs are attempts at transmission. Earthrise, the pale blue dot, the blue marble. These images have undeniably transmitted something. The first Earth Day, the environmental legislation of the 1970s, the global awareness of climate vulnerability that the photographs of Earth from space made viscerally real in a way that scientific reports could not. The transmission was not nothing. It was incomplete. Astronauts consistently report the same limitation. The photographs are not the experience. The photographs are evidence that the experience exists. Bill Anders spent decades showing people Earthrise, and what he always found was that people looked at it and felt something. But what they felt was not what he felt when he was there in that window, with the Earth rising above the grey silence of the moon and the black of space pressing in from every direction. Something was lost in transmission, something always is. Researchers at the Kepler Space Institute and the University of Stirling have been working on virtual reality simulations of Earth gazing from orbit 180-degree immersive experiences designed to bring the overview effect to people who will never reach space. Early studies show that even a simulated version of the view produces measurable changes. Increased scores on human nature connectedness, increased environmental behavior intentions, increased feelings of connection to other people. The shadow of the experience changes something. The full experience changes everything. What this means if you let yourself think about it. The most important perceptual experience available to a human being, the experience that reliably produces greater care for the planet, greater connection to other people, and greater clarity about what actually matters, is by its nature available to fewer people than the average stadium holds on a Saturday afternoon. The view that resets priorities is accessible only to those who can reach a specific altitude, at enormous expense through extraordinary physical and logistical training. Everyone else has to work with the photographs. This video is part of that work. And the actual specific hope, is that if you understand what those 700 people saw, and why it changed them, and what the physics of Earth's existence actually means, something in your own perception might shift. Not as far as theirs did, but in the same direction. That is what the photographs are for. That is what the words are for. That is what the science is for, not information. Correction. We have talked about the atmosphere as fragile. We have talked about it as thin. Now we need to talk about what it actually does, not as meteorology, not as climate science, but as the architecture of all possible experience. You are right now at the bottom of an ocean of air. The atmosphere is not above you in the way that a ceiling is above you, passive and inert. It is pressing down on you with the weight of 10 tons of air per square meter of your body, roughly the weight of a loaded semi-truck distributed across every square inch of your skin. You do not feel this because the air inside your body presses back with equal force. Every organ, every cell, every millimeter of tissue in your body has spent its entire existence in a state of equilibrium with that weight. Remove the weight, place an unprotected human body in the vacuum of space, and the pressure differential tears the body apart. Not dramatically, not explosively, but with the quiet thoroughness of physics asserting itself. At 8 kilometers above Earth's surface, the atmosphere is too thin to provide enough oxygen to sustain human consciousness. A person at that altitude, unprotected, loses awareness within minutes. At 12 kilometers commercial airliner cruise altitude, where you have flown on vacation, the temperature outside the window is minus 56 degrees Celsius. At 19 kilometers, the atmospheric pressure drops below what is called the Armstrong limit, the point where water boils at body temperature. Your blood at minus 19 kilometers would begin to vaporize. The Armstrong limit is 19 kilometers above your head. A fast runner maintained for 12 hours could cover that distance on the ground. It is closer to you than most major cities are. And above it, the thin blue line. And above that, the thin green line of airglow, the atmosphere marking its own edge in the dark. And above that space, not the romanticized space of science fiction with its nebulae and adventure, the actual space, the vacuum, the radiation, the temperature of minus 270 degrees Celsius in the shadow, plus 120 degrees in the sun, the silence that has no exit because there is no medium for sound to travel through, the default condition of the universe, the state of the cosmos in the absence of something extremely improbable. The extremely improbable thing is Earth. Here is what the atmosphere requires to stay in place. First, gravity sufficient to prevent atmospheric gases from escaping into space. Earth's mass, 5.97 times 10 to the 24th power kilograms, provides that. Second, a magnetic field to deflect the solar wind, the constant stream of charged particles the sun broadcasts in every direction. The solar wind strips atmospheric gases. The magnetic field deflects it. Earth's magnetic field is generated by the convective churning of its liquid iron outer core, a churning that has continued essentially without interruption. For approximately 3.5 billion years, and which is the reason Earth's atmosphere is still here. Both conditions are necessary, neither is guaranteed. Both exist simultaneously on exactly one planet in this solar system. From the window of the International Space Station, astronauts see both edges of both miracles. The thin blue line of an atmosphere maintained by gravity and a geodynamo that has been running since before complex life existed, and the thin green line of airglow that marks the upper boundary of the world, where everything they have ever known is alive and breathing. When they report feeling the atmosphere looks fragile from up there, they are not being poetic. They are being accurate. Mars formed from the same cloud of gas and dust as Earth approximately 4.5 billion years ago. It formed in the same solar system, subject to the same physical laws made of roughly the same raw materials. For hundreds of millions of years, Mars had something Earth still has: a magnetic field generated by its own iron core. And for the same duration, Mars had something else: liquid water flowing on its surface. We can see the evidence from orbit. We have seen it for decades. Ancient river channels carved by flows that were vigorous enough to move boulders. Lake beds, their basin floors smooth with the sediment that only a body of standing water produces over time. Delta formations, where rivers once met seas, the same fan. Shaped deposits you would find at the mouth of the Mississippi or the Nile, reproduced in the Martian rock at a scale suggesting the rivers that made them were enormous. Mars had water, not traces of water, not the hypothesis of water in quantities that would have filled oceans. Somewhere between 3.5 and 4 billion years ago, the Martian core cooled. It was smaller than Earth's core. Mars is roughly half Earth's diameter, 1/10 its mass, and it cooled faster. The convective churning slowed, the geodynamo weakened, and then gradually but inexorably the magnetic field collapsed. With no magnetic shield, the solar wind reached the upper atmosphere directly. Charged particles from the sun collided with atmospheric molecules and stripped them away, molecule by molecule, year by year, century by century, in a slow planetary exsanguination that took hundreds of millions of years and left nothing behind. As the atmosphere thinned, the pressure dropped. As the pressure dropped, the liquid water could no longer remain liquid on the surface. It evaporated at temperatures far below what water should evaporate at, driven into the thin air and then stripped away by the solar wind in turn. The oceans evaporated into space, the rivers dried to dust. The temperature dropped and kept dropping until the Martian surface reached its current average of -60 degrees Celsius, where it has been essentially unchanged for 3 billion years. Mars did not die from violence. It was not struck by a catastrophic impact, not swallowed by a star, not torn apart by gravitational tides. It died of cooling, of physics asserting itself slowly and patiently, and without any particular malice over the course of geological time. Somewhere on Mars there is a riverbed. It has been dry for 3 billion years. The water that carved it is gone, not frozen in ice, but stripped away atom by atom by the solar wind over the course of millions of years, until the last molecule of Martian water drifted into space. No one watched it happen. There was no one to watch. If Mars had produced in those early wet hundreds of millions of years a species capable of noticing its own atmosphere thinning, a species that could measure the magnetic field weakening and the pressure dropping and understand what it meant, they would have had perhaps 1 million years to respond. That is both a very long time and no time at all. Earth has produced a species capable of noticing. What they do with the noticing is still being decided. Mars is not an alien world. That is the thing we keep getting wrong about it. Mars is not the exotic, the strange, the incomprehensible. Mars is the baseline. Mars is what a rocky planet in a solar system looks like in the absence of the specific conditions Earth has maintained. Barren, cold, airless, geologically quiet, geochemically inert, that is the default. That is the planet you get when the physics are slightly less improbable. Earth is the deviation. Earth is the anomaly. Earth is what you get when a planet happens to be the right size, at the right distance, with the right composition, to maintain both a liquid iron core and a stable magnetic field and a habitable zone orbit and a large stabilizing moon to hold its axial tilt constant, all simultaneously, all continuously, for long enough that single-celled organisms could evolve into everything that has ever been alive. The list of necessary coincidences is long enough that astronomers who study planetary habitability have a word for it. They call Earth the pale blue dot. Sagan's phrase, which has entered the scientific literature as a technical term for a planet that has beaten every relevant statistical odd. When you look at Mars, when you put it next to Earth at the same scale, in the same frame, what you are looking at is the most honest argument anyone has ever made for taking care of something precious. Not an argument in words, an argument in worlds. In 1977, two spacecraft left Earth. Voyager 1 and Voyager 2 were built to study the outer planets Jupiter, Saturn, Uranus, Neptune, and then continue into interstellar space. They were instruments of science designed to measure magnetic fields and particle densities and plasma frequencies in the regions beyond the solar wind's reach. They were, by any reasonable accounting, two of the most successful scientific instruments ever built. But before they launched, Carl Sagan and a team of scientists, artists, and musicians with Sagan's future wife Anne Druyan as creative director, were asked to address a question that no mission to the outer planets should logically have required answering. If an alien intelligence finds this spacecraft in 1 billion years, what should it know about us? The result was the Golden Record, a gold-plated copper disc 12 inches in diameter. It carries 115 images: a nursing mother, a sequence of DNA, the solar system, a leaf, a snowflake, a demonstration of eating, drinking, and licking. It carries sound: surf on a shore, rain, falling wind moving through trees, fire crackling, the sound of a cricket, the sound of a whale, the sound of a mother's first words to her newborn child. It carries greetings in 55 languages, including one in Sumerian, a language spoken by no living person on Earth. It carries music from 27 cultures: Bach, Beethoven, Chuck Berry's Johnny B. Good, Blind, Willie Johnson, singing Dark Was the Night, Cold Was the Ground, Azerbaijani folk music, a Navajo night chant, Peruvian panpipes, a Senegalese percussion piece. The team argued passionately about the music. They argued about which greetings to include. They debated which images best represented humanity, not our achievements, not our monuments, not our power, but what we actually are. Every choice was deliberate. Every inclusion was argued for and against by people who understood that they were, in essence, writing a letter to the universe on behalf of 8 billion people who had not been consulted. There was also this Anne Druyan who had fallen in love with Carl Sagan. During the course of the project, recorded her own brainwaves on the disc. She sat in a laboratory in New York and let the instruments capture the electrochemical activity of her brain. And the night she made the recording, she was thinking about Carl. Not about the mission, not about the message. She was thinking about a man she had fallen in love with, and the particular quality of the thoughts a person has when they understand that love is real and mutual and astonishing. Carl Sagan and Anne Druyan fell in love during the Golden Record project. She had been working alongside him for weeks, arguing about music, translating greetings, trying to represent the full spectrum of human experience in a 12-inch disc, when something between them changed. On the night she was scheduled to record her brainwaves for the Golden Record, Anne Druyan was thinking about Carl. Just that, nothing cosmic. Not the stars, not the mission, not the universe. She was thinking about a man she had fallen in love with and the thoughts that arise when you realize the love is returned. Those thoughts are now in interstellar space. Voyager 1 is, as of today, approximately 24 billion kilometers from Earth. The signal it transmits back to us at the speed of light. The fastest velocity anything in physics can travel takes 22 hours to arrive. It crossed into interstellar space in August 2012, the first human-made object to leave the solar system. It is now moving through the void between stars, in a region of space where the sun is just another point of light, and Earth is not visible to any instrument the spacecraft carries. Voyager 1 will not reach the nearest star system for approximately 73,000 years. By then, if you can hold the number steady in your mind, the civilization that launched it will be as remote in history as Neanderthals are to us. The languages of 2026 will be as inaccessible as cave paintings. The nations, the borders, the political systems, the religious institutions, everything that structures human life right now will be as archaeologically distant as Mesopotamia is today. And still the Golden Record will be there. Still intact, still carrying Bach, still carrying a child's laughter, still carrying the brainwave pattern of a woman thinking about the man she loved. In a New York laboratory in 1977, while the world outside continued its ordinary catastrophes, while the Vietnam War was still ending, and the Cold War was still cold, and Humanity was still figuring out what it was and what it owed to itself. We sent a love letter into eternity. We wrote it, knowing no one would receive it in our lifetimes. Probably not in the lifetimes of any civilization recognizable as descended from ours. We wrote it and launched it into the dark and let it go. And here is what the golden record means if you let yourself feel the full weight of it. When we were given the task of representing ourselves to the universe, no constraints on what to include, no audience to perform for, no political incentive to present ourselves as powerful or advanced, this is what we chose. Not our weapons systems, not our GDP, not our monuments or our empires or our scientific achievements. Music, rain, a mother's voice, the sound of surf, a woman's thoughts of love. We chose the softest things, the most human things. We chose what we actually were when no one was watching. Carl Sagan called Earth the only home we've ever known. The golden record is what that home sounds like when the people who live in it are asked to describe it honestly. It sounds like music. It sounds like rain. It sounds like a woman in love. Victor Glover, NASA astronaut, crew, Dragon pilot, one of the people who has looked at Earth from the window of the International Space Station, described something he called the sea level effect. Not the experience of being in space, the experience of coming back down. He said, you come back to sea level and then you have a choice. Are you going to try to live your life a little differently? Are you going to really choose to be a member of this community of Earth? The choice is real, and the record of what the 700 people who have had the direct experience choose, when they return, when the overview has settled from an overwhelming sensation into a permanent part of their understanding, is instructive. Nicole Stott came back and became an artist. She creates paintings that attempt to render Earth as she saw it from orbit. The luminosity of the atmosphere, the specific quality of the light over the Pacific, the way weather systems look like living organisms from 400 kilometers up. She says she paints because photographs don't capture it. Language doesn't capture it. I still wanted to see Florida, she said of looking down from the ISS. But Florida had just become this special part of home, which is Earth. We're all Earthlings. Russell Schweickart, who orbited Earth during Apollo 9 in 1969 and had one of the most intensely described overview effect experiences in the record, a 40-minute spacewalk during which he hung in space and watched the whole planet turn below him. Every border invisible, every ocean connected to every other ocean, spent the following 50 years working on planetary defense, on the detection and deflection of asteroids. The logic as he described it was simple. If you understand that everything is here, on this one luminous object, you take seriously anything that threatens it. Ed Lu co-founded the B612 Foundation. Ron Garan developed the orbital perspective, a framework for applying systems thinking to global problems, drawn directly from the experience of seeing Earth as a system without borders from outside. Wubbo Ockels, Dutch astronaut, spent the last years of his life working on renewable energy and environmental policy driven. He said, by the visceral understanding he had acquired from orbit, that the atmosphere is thin enough to see through and finite enough to fill. The pattern is consistent. The astronauts who saw Earth whole came back and tried to protect it, not because they were trained to, not because it was in their mission parameters, because they saw something that made the stakes undeniably clear. And here is what this means for the 8 billion who haven't been to space. The research on virtual reality overview effect experiences, conducted by psychologists at the University of Stirling and the Kepler Space Institute, shows that even a simulated partial version of Earth gazing from orbit produces measurable changes in environmental behavior and human nature connectedness. You do not have to leave the atmosphere to be affected by the view. The photographs carry something. The astronauts' words carry something. The accumulated record of 700 people returning from space with the same changed understanding carries something. The question which the overview effect research frames with a precision that most policy discussions lack is not whether seeing Earth whole changes people. It does. The question is how to give enough people enough of the experience to matter. How many people need the correction before the correction propagates? How many need to understand viscerally, not intellectually, in their bodies, not just their minds, that the atmosphere is thin, that the planet is improbable, that what Mars lost we still have, and that everything worth preserving is inside the thin green line? This is not a rhetorical question. It is the most practical question of the century. You were alive for all of it. If you grew up in America between 1955 and 1980, you watched it happen in real time. You watched Alan Shepard become the first American in space on a black and white television, your parents standing in the kitchen with their arms crossed and their breath held. You watched Neil Armstrong step onto the moon and say words that were broadcast. Live to 600 million people, 1/5 of the entire human population, the largest audience in history to that point, all watching a man from Ohio put his boot into dust that had waited 4 billion years to be touched. You watched Earthrise become a poster on the wall. You watched Carl Sagan explain the pale blue dot in 1990 and felt perhaps the specific ache of a person who had grown up in the space age watching its ambition contract. You are the generation that watched humanity learn what it was looking at. And now the instruments have gotten better. The James Webb Space Telescope launched on December 25, 2021, Christmas Day, the same season of the year that Apollo 8 orbited the moon 53 years earlier. Webb is the most powerful space telescope ever built, designed to see farther back in time than any instrument in history, capturing light from galaxies that formed less than 1 billion years after the Big Bang. Light that has been traveling for 13.5 billion years and has finally arrived at a mirror in space the size of a tennis court made of 18 gold. Coated hexagonal beryllium segments that fold out like a flower and align to a precision measured in nanometers. In its first year of operation, Webb captured images of the deep universe that made grown astronomers cry. Not for the grandeur, though the grandeur is real, but because the images contained something Hubble never quite resolved: the chemical signatures of distant planets' atmospheres. For the first time, we have a telescope capable of asking a specific and previously unanswerable question: is there another pale blue dot out there? Is there another planet circling another ordinary star in another unremarkable galaxy, where the physics happened to align and the iron core kept churning and the magnetic field held and the oceans didn't freeze or boil and something began, single-celled and patient, and 4 billion years from a species capable of asking the question? We do not know the answer yet. We are looking. And while we look, while Webb scans the atmospheres of distant worlds for the chemical fingerprints of photosynthesis and respiration and liquid water, something else is happening closer to home. The Artemis program, NASA's first return to deep space since 1972, is sending humans around the moon again. The Artemis 2 crew, which includes the first woman and the first black astronaut to travel to lunar distance, will look out their window and see what Frank Borman and Bill Anders and Jim Lovell saw. Earth whole rising over the lunar horizon. Small, round, impossibly alive. They will be the first people since December 1972 to see it with their own eyes. The next generation will not have to work entirely from photographs. We went to the moon and discovered that Earth is fragile. We went to the edge of the solar system and discovered that Earth is lonely. We sent a probe to Mars and discovered that Earth is improbable. We built the most powerful telescope in human history and aimed it at the sky and asked, is there another world like this one? And then we held our breath. Every mission outward has been, at its deepest level, an argument for the importance of here. There is a photograph. It was taken on Christmas Eve in 1968 by a man who was supposed to be photographing something else. He was supposed to be documenting the moon's surface craters, ridges, the grey machinery of a dead world. And then his spacecraft rotated, and something appeared in his window. And he fumbled for film, and in 40 seconds of improvised urgency, he captured an image that changed the world he had temporarily left behind. The image shows Earth above the moon's horizon, small in the frame, which is part of what makes it work, part of what makes it devastating, because the smallness is accurate. The moon is larger in the photograph than Earth is. The barren silence of a dead world fills most of the frame. And in the corner above the grey and the nothing is a blue and white marble, luminous beyond any reasonable expectation, hanging alone in the absolute black. Everything you have ever loved is in that corner. Everyone you have ever known. Every place you have ever been. Every meal, every song, every conversation that mattered. Every ordinary Tuesday afternoon that you didn't notice at the time but remember now with a specific and inexplicable tenderness. All of it is in the corner of a photograph taken by a man who was surprised to be looking at it. We built rockets because we are the kind of creature that cannot be told there is a horizon without wanting to cross it. We pointed them at the sky because the sky was in the way of the next thing. We sent men to the moon because the moon was there, and we had the technology. and the Cold War had made competition a necessity, and because beneath all of that, we are the species that has always gone. The species that walked out of Africa and across the land bridges and into every climate this planet offers. The species that built boats for oceans it had never seen and still set sail. We went to the moon to go to the moon. But what we found when we got far enough away was the thing we had been too close to see. What we found was Earth. Not the Earth of maps and textbooks and geopolitics and resource extraction, the real one. The one that physics made. The one with the skin of an apple standing between its oceans and the vacuum. The one that sits in a window of orbital distance so precise it can be measured in percentages. The one whose iron core has been churning for 3.5 billion years to maintain the magnetic field that holds the atmosphere in place, that keeps the water liquid, that makes the chemistry possible, that produces everything that has ever been alive. The one that Mars almost was. The one that contains on a 12-inch gold disc hurtling through interstellar space at 64,000 kilometers per hour, the sound of rain and the sound of surf, and the sound of a child laughing and the brainwave pattern of a woman thinking about love, chosen by the most rigorous minds in science as the best answer to the question, what are you? We are the rain, we are the child's laughter, we are the love, we are the species that went far enough away to finally understand that. Somewhere tonight a person is sitting in the cupola of the International Space Station. The cupola is a dome of 7 windows pointed at Earth, the astronaut's name for the room where you go to look. They have been in orbit for weeks. They have watched 16 sunrises a day, one every 90 minutes, the sun appearing and disappearing with a speed that renders all previous understanding of time irrelevant. They have watched thunderstorms from above, not the grey overcast that you see from the ground, but the actual electrical architecture of a storm, the lightning branching through clouds lit from inside the whole structure, visible at once. They have watched the aurora australis, the southern lights, rippling across the atmosphere in curtains of green and violet, the solar wind and the magnetic field conducting a slow conversation in light that no one on the ground was awake to see. Tonight they are not looking at the storms. They are looking at the cities. From 400 kilometers up at night, cities look like something alive, not the ordered grids of a street map. Glowing organisms reaching outward from centers of dense light into networks of connection. The whole structure looking, as astronaut Ron Garan observed, like a photograph of a neuron. Every city a ganglion, every highway a synapse, every lit window a thought, no borders, no boundaries, no lines on the ground to tell you where this country ends and the next one begins. From up there the only distinctions are natural, the edge of the ocean, the shadow of the mountains, the dark gap where the Sahara absorbs the light, and the bright dense clusters where the great river deltas have always gathered human life. 80 years ago, 2 nations were bombing those river deltas, those coastal cities, those dense human clusters with everything industrial chemistry could produce. Today the person in the cupola, who may be American, Russian, Japanese, Canadian, European, or the representative of any of the growing number of countries with space programs, watches those cities glow without borders and thinks the same thing every astronaut thinks. We are all in here together. There is nowhere else. We will go further. The Webb telescope will find eventually an atmosphere on a distant exoplanet with oxygen in it, the chemical signature of photosynthesis, the fingerprint of life. Or it won't, and the silence will be the most important data point in history. The Artemis missions will return humans to lunar orbit, and some of them will see what Bill Anders saw, and they will come back changed, as he was changed, and they will spend the rest of their lives trying to explain it as he did. Eventually, in decades or centuries or millennia, on a timeline that depends on choices we make now, humans will stand on the surface of Mars and look up at Earth in the Martian sky, a blue point of light in the rust-colored dark, and understand in their bones what Carl Sagan understood in his mind, that everything that matters is in that point of light. Every exploration we make outward will send back the same message. Look at what you have. Look at how extraordinary the ordinary is. Look at the thin green line. We have spent 60 years going out there and coming back with photographs of here. We have built telescopes to look at the deep past of the universe and discovered in the looking how improbable our present is. We have sent a gold disc into the void carrying the sound of rain and received back, at 64,000 kilometers an hour, a slow, inescapable answer to the only question that ever mattered. The answer is this: you are on the right planet. It is the only one. It is enough to break your heart every day when you understand what it is. And when you understand what it is, when you really see it the way the astronauts see it, the way the photographs are always trying to help you see it, it is more than enough to make you whole. We did not go to space to escape the Earth. We went to finally see it, and what we saw was enough to break your heart, and more than enough to make it whole again.